right, welcome to the variation problems video for MathCelebrity.com. My name is Don Sevcik, founder of Math Celebrity, and today you're going to learn how to solve and recognize variation problems. Now, in algebra, there's two types of variation problems: direct variation and inverse variation. So first, let's define variation problems. And what they do is determine a relationship function between two variables. First, direct variation. I like to use the analogy, it's like a relationship. You're either in a relationship or you're married. So what happens to one partner directly affects in the same manner what happens to the other partner. So if your husband's doing well in direct variation, then you're doing well. If your husband's not doing so well, then you're not doing so well. And number two, on the flip side of that, we have inverse variation. And the analogy for this is divorce. And the way this works is one variable goes in reciprocal to the other variable. Now, you're probably familiar with reciprocals and fractions. So, for instance, if you have the number 2, the reciprocal is 1 over 2, because when you multiply 2 by 1 over 2, or a number by its reciprocal, you get 1. And this is an easy way to think about and approach inverse variation problems. So let's go to the next slide. We've got direct and inverse variation problems. Let's start with direct variation problems and how you recognize you have a direct variation problem. Usually there's 4 or 5 very specific phrases for you to watch out for, and they go like this: vary directly, vary as the square of, vary as the cube of, or vary as the square root of. And another way, if you want to think in terms of what it's not, make sure you don't see the term inverse or inversely. That's how you know it's a direct variation problem. And on the flip side, inverse variation problems, they read almost the same as direct variation with one key word inserted: inverse or inversely. So x varies inversely as y, y varies inversely as x, as the cube of x. So look for the word inverse or inversely that tips you off to an inverse variation problem. All right, let's start with a real live direct variation example. The problems read something like this: y varies directly as x. When y is 36, x is 4. Solve for y when x equals 6. Now, direct variation problems imply a y equals kx relationship in this problem, because we've got y and x. So k is called the constant of variation. It has a direct effect on x, which affects y. We'll start with the initial statement. The initial statement is when x equals 4, y equals 36. Step 1, we set up our constant of variation equation. Remember, it's y equals kx. Now in this case, y is 36 when x is 4. So we've got 4k equals 36. If we solve for this using division or our Math Celebrity calculators, we get k equal to 9. K equal to 9 is our constant of variation. Now we're going to take that and move to the second part of this problem. The problem asks for y when x equals 6. Well, remember, y equals kx is our direct variation function. We know k is 9, right? So we're going to have y equals, and we know x is 6. So if we take this y equals kx, k is 9, x is 6, we multiply, down here we get y equals 9 times 6, which is 54. So we've solved our problem. In direct variation, what is y when x is 6? The answer is 54. Let's take an inverse variation example. And the problem reads y varies inversely as x. There's the key word, inversely. Y equals 36 when x equals 4. We want to solve for y when x equals 6. Now if you notice, we use the exact same numbers, We're just using an inverse problem. Now, inverse variation implies a y equals k divided by x relationship. I'm going to go back to the previous slide. Direct variation is y equals k times x. Inverse variation is k over x. So remember the inverse or the reciprocal. We start with our initial statement. Y equals 36 when x equals 4. We want to use our k for the constant of variation. So it's y equals k over x. So we've got k over 4, x is 4, equals y, which is 36. We want to solve for k. Now if we cross multiply 36 times 4, we get k equals 144. This means that our inverse variation equation is x equals 144 divided by y. Step 2, the problem asks, what is y when x is 6? Well, if we solve for this, we get 144 divided by 6 equals 24. And I think I flipped the variables here, but if x is 6, we'd have 144 over x. 144 over 6 equals 24. So we've solved our inverse variation problem. We'll do one more, and you'll see these sometimes, direct variation squared example. We'll start with y varies directly as the square of x. Y equals 100 when x is 2. Solve for y when x is 6. Well, the direct variation squared relationship implies a y equals kx squared relationship. We take our initial statement, y equals 100 when x is 2. This means that we've got x squared, which is 2 squared, k equals 100, because our constant of variation equation as the square of x is this, y equals kx squared. We simplify, we get 4k equals 100. So if we divide each side by 4, we get k equals 25. Now the problem asks, what is y when x is 6? We know our variation equation, because y varies directly as the square of x, is y equals kx squared. K is 25. We want to know what y is when x is 6. So we plug in 6 to this equation. We get 25 times 6 squared. Well, 6 squared is 36, and 25 times 36 is 900. So you've solved the direct variation squared example. When x is 6 in this problem, y is 100. That concludes our 3 examples in our tutorial of direct and inverse variation. Now, if you're on the Math Celebrity site, you're already on the variation calculator, so you know what to do. If you're finding us first from YouTube or finding us not on the Math Celebrity site, what you do is you go here in the search engine and you type variation. The search engine is going to find our variation calculator. You can have joint variation equations, which is going to be another video. We want variation equations. So you go ahead and click this link, and it will load the variation equation calculator. And you can toggle here your drop down. So these are your variable 1. You could say what kind of inverse or what kind of relationship is it? Direct, inverse, square of, cube of. You pick your second variable here, pick your first and second condition, and then finally what's given for what's solved. Once you have everything in place, you click calculate variation, and it's going to run your problem and walk you through step by step how to solve the variation equation. And at the end you get your answer. So that concludes today's variation equation video. Again, my name is Don Sevcik. Thanks for watching. I will see you in the next video.